Hi everyone, this is Isaac Rosenfeld. I am a Solaris product manager and I'm joined by Nicholas Drew, a senior core kernel architect in the Solaris engineering team. And today we'd like to talk a little bit about some of the hot new things that we've announced in Solaris 11.2 with a focus on networking technologies. So Nicholas, we are announcing Solaris 11.2 this month at the end of April, April 29th, with a big event in New York City. And there are a number of important technologies that make Solaris 11.2 extremely appealing. What are some of the specific networking aspects of Solaris 11 as a whole that you can share with the rest of the community that would make people really interested in looking at it and looking to understand how they can derive value out of networking in Solaris 11 now?
Yeah, Isaac. So as a lot of people know, we a few years ago we released Solaris 11. That was a pretty big release for us. So we added quite a bit of functionality built into the OS for, virtualization and built-in SLA and these type of things. And that was really exciting. We're pretty far ahead in terms of the feature these type of features, as well as performance. So we improved Solaris performance quite a bit, as you've heard. So with Solaris 11.2, we've taken these features to the next level, basically. So some areas. So there's way too much to discuss in just the few minutes we have today. But just to give a highlight on the major areas, one is taking network virtualization to the next step and taking that out of the machine into the data center. So one of the, as and everybody knows, cloud is the word of the day or the word of the decade or whatnot. So how could we take these built-in network virtualization capabilities and expand them into the cloud, into the network, into the data center itself, to enable our customers to build their own distributed virtual network infrastructure. So just like we had before, the very easy commands to create a VNIC, configure virtual switching and these kind of things. Now we can basically do the same thing, also from Solaris, but now across a set of machines. We'll talk about that a little bit later. But that's kind of one key area is, built-in distributed virtual networking with what we call elastic virtual switches. So that's one area. Another one is, one of the things that we're hearing, all the time from customers is how can I, simplify my administration, right? So I have all these applications, I have all these OSs, I have the network, and I have all these things and all these people managing all this. And how can we automate a lot of that, process, right? That management. So we step back and saw that, well, what, since we have in Solaris, we have integrated networking, integrated virtualization, and we already know how to run apps, right? We're an OS. So how could we allow the applications to directly tell the OS about what type of networking traffic they have, right? So some applications might have high priority traffic versus regular traffic. Some applications may be multi-tenant, right? So maybe some applications may have maybe running as a platform as a service layer, for example. So they have multi-tenant, and they would want to allocate network traffic bandwidth to multiple tenants, for example. So what we've added are a set of socket API extensions, so new socket options basically, to allow applications to directly tell the OS what kind of SLAs or network bandwidth and so forth they want to create for connections or associate with sockets. So that's one area that's what we call the application driven SLAs, basically application driven SDN. That's what that enables, right?
So that's in addition to some of the commands that have already been introduced previously in Solaris 11, right? With empowering the administrators to control flow of applications and avoid any unnecessarily or unapproved denial of service attacks or some applications taking up much more bandwidth than necessary. There's a command we introduced, FlowADM and FlowStat, two commands, and now we're extending that into the application layer to allow application developers to use their own socket calls and interfaces to have the applications themselves do this, freeing up the administrator. Sounds like that's really...
Exactly. Yeah, one use case that we use frequently is the problem of the network backup, right? So network backup starts, and the network backup application will be optimized to go as fast as possible, basically, right? So it will if you don't throttle it, it will basically suck up all your network bandwidth, and then your network application doesn't have anything to run on, right? So it's a big self-inflicted denial of service attack, that some people will go through. So with FlowADM, we could basically go on the side, and an administrator could go on the side and create a flow for backup, and then limit the traffic used by that type of traffic, right? But so that works for a few services, right? But a lot of applications are more very dynamic, right? So they will create applications on the fly, they will create tenants on the fly in a cloud environment. The more cloud-ish your data center becomes, the more dynamic the workloads are, right? So having to go back and forth between, FlowADM and what is happening, and back to FlowADM, what is my connection? It just doesn't scale, right? And also FlowADM was limited in that you could, it was not really working for individual connections. It was more of a, it was more tailored for services, per service SLA, basically. But if you want to track individual connections, you don't know necessarily what the port numbers will be used for these connections, right? So it was pretty, it was useful, but did not scale to cloud, workloads, or to large number of connections. So now with these APIs, we can hide all of that complexity away, so you don't have to use the command on the side. Let the application drive it, and then it can be a lot more dynamic, right? Depending on what the application is doing, automatically the application will go in and tell you, okay, here's this new connection. I want it to have a maximum bandwidth of so many megabits, or I want it to be, high priority because it's carrying my, my heartbeat traffic, for example, and things like that. And we are working also with other teams at Oracle for them to use these APIs for their network traffic, right? So, for example, multi-tenant database, or rack heartbeat traffic, and so forth. So that's pretty exciting.
So it sounds like, number one, there's the notion of a distributed virtual switch with SDN that we're providing in Solaris 11.2. Number two, the ability to have applications actually drive networking behavior and articulate their needs on their own without having the administrator be as involved as in the past. So with some of these things, it sounds like the complexity of the system's capacity and the ability to avoid faults or recover from faults becomes increasingly important, right? Can you mention some of the things that we're doing in managing advanced I/O capabilities, and also observability and diagnosability of networking protocols and network traffic?
Yeah, sure. So there's quite a few aspects to this, right? So one is, while we're talking about distributed virtual networking capabilities, something that we try to do is to make it as easy as possible to manage, right? So really integrated with the OS. You don't really have to go fetch, and install some different packages from here and there, and have to worry about which one is compatible with your stack and your, hypervisor and so forth, right? All you have to do is, point Solaris to your Solaris repo, install our Elastic Virtual Switch package, and boom, you have the components there. Now, a few steps of configuration to set up your environment. You need to identify a controller and things like that, and then so a few easy steps, and then you have a distributed virtual network infrastructure, basically, and what we try to do is, provide basically an OS-like environment to manage a distributed virtual switch. So we provide, for instance, a simple-to-use command to administer your, elastic virtual switches. So you can go on your controller node and you create a virtual network for your data center in a single command, right? So we don't want to go through all the arguments and stuff like that here, but you basically run a command EVSADM, to create your elastic virtual switch, and then it's basically now exists in your data center. Now you can go on any of the nodes of your network, right? Any of these compute nodes. You can create a VNIC and connect that VNIC to that elastic virtual switch, and automatically we expand that virtual switch to the node where you're running your workload, where you're running your VM, basically. So and internally, our architecture is basically configuring the network on the fly, configuring the fabric on the fly as you perform these operations, as the load moves around. So when you create an elastic virtual switch, depending on the type of network fabric you have underneath, we will go in and program that network fabric to do the right thing. So as the user, you see a very clean, simple to use distributed virtual network infrastructure. And then underneath, we handle all the complexities of configuring the network and distributing the information to the right place. So command line, it's one thing, right? So but it's still very Unix-ish, right? But at the same time, we realize that a lot of the data center management is moving towards a more dynamic DevOps type of environment, right? So people are, not just running commands and using GUIs, but they're also running a lot of scripts and applications to drive their infrastructure, right? So we also provide a set of APIs that allow you to do that as well. So that command underneath is driving a set of APIs that we expose as well to the administrator, or to the user. So you can write a script that basically on the fly will configure your distributed virtual network switches. Then you can write your own Python, script or whatnot to drive that. So that's one aspect.
So by extension,
yeah, go ahead.
By extension, then this sounds like a very, very important aspect of Solaris for those who are looking to deploy Solaris in an OpenStack environment, right? Because we are providing a number of OpenStack modules. OpenStack as a cloud software actually has a number of these attributes that we are bundling, and on the networking side, right, when somebody's running Neutron, they would be making calls into the interfaces that we publish for EVS management.
Exactly. So what we did is that we basically implemented an OpenStack. So Neutron is the networking component of OpenStack, basically. So we implemented an OpenStack Neutron module on top of EVS, on top of our APIs, Elastic Virtual Switch APIs. And if you're an OpenStack user, either through OpenStack APIs or from Horizon, anything like that, and you create Neutron networks, virtual networks, and all these things, and virtual ports, then we implemented that Neutron module to call into our APIs to do that automatically for the user. So if you want, you can use the Solaris tools. If you want, you can use the Solaris APIs. But if you're an OpenStack user, you can use OpenStack APIs, right? It's your choice.
And so we are bundling this starting with 11.2. We have a number of these OpenStack components that we're bundling, including Nova, including Glance, Neutron, Horizon for management of the entire flow.
I think before we wrap up, there's quite a bit we've done to improve high availability and how we integrate high availability with virtualization. So I think that's something we'll talk about more in a future podcast or video. There's other things that we've done around, performance, to improve scalability and improve latency. So we will talk about that as well, and we have even more down the list. So this is just the beginning of a series of videos, and it will be pretty exciting to share all of these new things with the community and with our users.
I'll also be speaking with Girish Modalbail and ask him to possibly do an EVS demo in a very similar format like we've had. I'd like to conclude and thank you, Nicholas, for joining us this afternoon. If you haven't tried Solaris recently, please go ahead to oracle.com/Solaris, grab a copy, and explore some of the excellent features that we've introduced in this particular release. Thanks for watching, and stay tuned for more on this series. Bye for now.
Thanks, Isaac. Bye-bye.
Thanks, Nicholas.